Welcome to Spaceverse, your portal to cosmic adventures. Would extraterrestrial life be possible? Some intriguing hints may have recently been revealed by the James Webb Space Telescope. From a 0.7 trillion kilometers away, the powerful telescope has found odd, bright lights that seem like city lights. The nearest exoplanet to our solar system, Proxima Centauri b, is the source of these lights. Is it possible that this is a sign from another planet that another civilization is trying to communicate with us? An extraterrestrial metropolis? The question of whether or not our solar system is indeed unique has perplexed astronomers and scientists for decades. What if, beyond our solar system, there is a vibrant, living planet? That optimism has been sustained by every peculiar radio signal and atmospheric abnormality. The James Webb Space Telescope JWST has made a stunning finding that might alter the course of history. It appears to have detected evidence of an extraterrestrial civilization located far outside our solar system. Something out of the ordinary was picked up by the JWST as it peered into space from the exoplanet Proxima Centauri b, which orbits the star nearest to Earth. The telescope detected dim lights that appeared disturbingly similar to the illuminated urban areas that can be seen from Earth's orbit. Are these lights a sign that this faraway planet is inhabited? There's a great deal of enthusiasm among scientists about the possibilities. It would be a monumental finding proof that sentient entities exist beyond the realm of science fiction if confirmed. The source of these peculiar lights is a planet more than 7 trillion miles away. They stayed out of sight for a long time, but we were ultimately able to detect them when our technology improved. Could this be a spaceship taking in the night sky of another planet? On the other hand, may we be missing a more obvious explanation? Might there be other luminous cities 4.2 light-years from Earth? Planet Proxima Centauri b isn't like other stony worlds. This extraterrestrial body acts differently like Earth, which is known to soak up solar radiation during the day and release it as heat at night. As a result of its tight orbit around Proxima Centauri, the host star, unusual atmosphere patterns are produced. Columbia University astronomer David Kipping compares trying to understand our planet to attempting to solve a cosmic puzzle. Neither task is easy. By monitoring the surface heat flux on Proxima b, the formidable infrared detectors of the James Webb Space Telescope were instrumental in finding these enigmatic lights. Scientists think they can go farther into studying Earth's atmosphere and climate with the help of the telescope because it can see in infrared light. Scientists are eager to find out if the planet's surface experiences extreme temperature changes with each revolution, or if there is an atmosphere that can stabilize temperatures. If Earth were to lose its atmosphere, the side of the planet that faces the star would get extremely hot, while the side that faces the night would get extremely cold. Proxima b may have the necessary circumstances to host life, or at least some kind of it, if it can handle these tremendous changes. Finding faint lights in the night sky is one of JWST's most fascinating capabilities. When it comes to picking up feeble signals in the middle of nowhere, JWST really shines. Its infrared light detection capabilities make it an ideal instrument for tracking Proxima Centauri b's activities throughout the day and night. Lights on Proxima b might indicate sophisticated technology comparable to or even beyond our own, assuming they are indeed artificial. Solar panels, which would absorb light from the planet's star, have been the subject of conjecture among certain scientists. City lights fueled by that energy might illuminate the night side, much like Earth's cities do after sunset. With an orbital period of only 11.2 Earth days around its star, Proxima Centauri b provides ample opportunity for researchers to investigate it up close. Thanks to its pinpoint accuracy, JWST can stay vigilant throughout the day and night, scouring the planet for any signs of life. This planet may contain more than just rocks and dust. If the lights are true, it may even harbor a whole civilization. Is the night sky being illuminated by an extraterrestrial metropolis? The following stage is to determine if Proxima Centauri b contains the necessary elements to sustain life. Planets with oxygen, water vapor, or methane in their atmospheres are highly likely to support life. However, these aspects aren't straightforward to capture and analyze. In its incredibly precise examination of the planet's atmospheric light, JWST will be able to detect these compounds. Despite the telescope's primary purpose is studying faraway star systems and galaxies, it excels at measuring the gases on other planets. It has the ability to detect 3 gases that are crucial to life: carbon dioxide, water vapor, and methane. However, it has trouble detecting bound oxygen, which is an important sign of biological activity. Nonetheless, it has the ability to detect ozone, which is another indicator of a stable, hospitable atmosphere. Discovering these components on Proxima Centauri b would be a major step toward proving the possibility of life beyond Earth if JWST is successful. Could there be extraterrestrial life, complete with sentient creatures, thriving in a climate quite similar to our own? If Proxima b's air is habitable and waiting to be found, what then? We're getting closer to an answer to the age-old question with each observation made by the James Webb Space Telescope. Are we alone in the universe? What we see as a glimmer of light from Proxima Centauri b could be the proof that mankind has been seeking all along. This finding demonstrates the efficacy of our new instruments regardless of whether the lights have a natural explanation or not. Thanks to the telescope, we can now discover faraway planets like never before since it can detect the faintest spacecraft signals. The options are limitless. Imagine for a second that we communicate with the life on Proxima b, or that they communicate with us. Is it possible that the next finding will prove that we are not alone? At this point, our only option is to keep searching, keeping an eye on the stars for any further indications of faraway life. Whether the truth is on Proxima b or further away, the hunt is far from over. Exploring the cosmos in search of life. New methods of cosmos exploration are being enabled by the James Webb Space Telescope. Even though it can only see the nearest habitable planets, it is revealing astonishing details about the universe beyond our solar system. Yet, this is only the beginning of our thrilling journey. With the extremely large telescope ELT scheduled to open in 2028, scientists will have access to even more sophisticated capabilities in a few years. Imagine for a second a world where the ELT could probe the atmosphere of a distant planet in search of clues that it could be habitable. By utilizing ingenious methods to obstruct the dazzling light of neighboring stars, the ELT will surpass Webb's visibility. Imagine trying to see a bird in the sky by covering your eyes with your palm. Astronomers will be able to analyze the feeble light reflected off faraway planets more clearly when there is less brightness in the sky. The problem arises, however, when trying to determine whether or not gases associated with Earth's life, such as oxygen or methane, are actually created by volcanic eruptions or some other naturally occurring mechanism. Finding evidence of life isn't simple, and scientists must be careful not to confuse planetary chemistry with extraterrestrial biology. Is it possible that there is life beyond our perception, waiting to be found? For the time being, JWST is still our greatest hope for obtaining answers. Although it may not be able to thoroughly investigate every faraway country, it is already transforming our understanding of the cosmos. The telescope has taken some breathtaking pictures and uncovered some new information that might explain the birth of galaxies and stars. Webb is also poring over exoplanet atmospheres with its ultra-sensitive filters, searching for signs of water and carbon dioxide that may indicate habitable circumstances. We can see what kinds of discoveries future telescopes like the ELT will be able to make because of this. Some astronomers have gone in a different direction in their quest for life, as JWST searches the heavens for hints. The search for extraterrestrial intelligence (STI) was launched in 1984 by astronomers Jill Tarter and Thomas Pearson. The basic premise was that extraterrestrial intelligence could be communicating with us through radio waves that we are simply oblivious to. Over the course of several decades, the 42 radio telescopes that make up the Allen Telescope Array in California have been utilized by SETI to search for extraterrestrial communications. Because they do not degrade as they travel across space, radio waves are ideal for communicating over great distances. However, the truth is that SETI has not detected any signals that can be confirmed as being from another planet, even though they have been searching for more than 30 years. Still, Tarter holds out hope, thinking that modern technology may at last provide a breakthrough. Is it possible that the solution to a timeless mystery, are we alone in the universe, may be more accessible than we realize? An unusual discovery has actually generated some buzz already. The Webb telescope allegedly detected lights on a neighboring planet, which could be the illumination of an extraterrestrial metropolis, according to recent speculation. Despite the lack of confirmation, anticipation for Webb's mission is rising. With its vantage point 1 million miles above Earth, the telescope can see into the farthest corners of the cosmos, revealing previously unknown details about the birth of stars, galaxies, and planets. Finding more hidden mass in galaxies than predicted, it challenges current beliefs about the universe's development. The more information Webb uncovers, the more engrossed we become in the mystery of life beyond Earth. Thanks to the telescope, we are getting closer to the answers to some of the most profound mysteries that have ever fascinated humanity with each planet it scans and atmosphere it studies. What Webb has found is only the tip of the iceberg when it comes to the ongoing hunt for extraterrestrial life. The possibilities will continue to expand as more and more telescopes, like as the ELT, join the quest in the years to come. People have been staring up at the stars for ages, trying to figure out if they're alone. With the Webb telescope spearheading the effort, the long-standing question seems to be getting closer to a solution than ever. As our space exploration continues, who can say what bizarre new worlds and amazing discoveries may be in store for us? The enigmas of extraterrestrial life revealed. The James Webb Space Telescope allows us to explore space at a greater depth than in the past. This incredible innovation is shedding new light on faraway planets, which might provide long-sought answers to many of our most pressing problems regarding extrasolar planets. Planets around other stars seem like a pipe dream only 20 years ago. Showing how far our inquisitiveness and technological prowess can carry us, astronomers have now discovered more than 4,000 exoplanets. Even more astounding is the fact that NASA estimates there are potentially trillions of other planets in the universe that are yet to be found. Researchers are hell-bent on continuing their quest to find extraterrestrial life. On occasion, they come upon hints that pique their interest. While passing Jupiter, the Galileo spacecraft made an exciting but unintentional discovery. It detected an unusual signal known as the vegetation red edge, which may indicate the existence of vegetation. For the first time, we had discovered what appeared to be a biosignature, or indication that life may exist in environments other than Earth. By analyzing surface light reflections, the VRE cleverly detects life. In order to find planets in the Goldilocks zone, that region surrounding stars where the temperatures could be ideal for life, scientists are now employing this strategy with the Webb telescope. The JWST has the potential to open a new era in space exploration by detecting more of these signals, which would allow us to delve farther into the mysteries of the universe. Could we soon find extraterrestrial life? Among the many impressive capabilities of the JWST is its capacity to read the atmospheres of faraway planets. Some chemicals in a planet's atmosphere absorb light at specific wavelengths, creating a fingerprint of the planet's surface. The JWST can interpret these patterns and learn about the composition of these distant atmospheres via spectroscopy. There are a lot of planets the size of Earth with nitrogen, oxygen, and carbon dioxide in their atmospheres. These elements are essential for all known forms of life, but scientists are also on the lookout for strange compounds that might indicate the presence of extraterrestrial life. The discovery of chlorofluorocarbons on another planet by Webb would be a major event. It would be a monumental finding that would cast doubt on the idea that life exists outside of our solar system if that were to occur. An fascinating new frontier for astronomers to study, this discovery would expand our knowledge of extraterrestrial life. Many of us tend to picture extraterrestrial life as requiring the same hospitable circumstances that humans do, such as moderate temperatures, an abundance of water, and fresh air. However, extraterrestrial life may be substantially more complex and challenging than we anticipate. As an example, consider extremophiles. Earth is home to these microscopic creatures that survive in circumstances that defy logic. Others can endure extremely acidic conditions with pH levels below 3, while still others can withstand boiling temperatures over 250 degrees Fahrenheit. We can see that life can adapt in incredible ways from the existence of these extreme forms of life. Even as we go on in our quest to find habitable planets, it becomes more apparent that life may live in settings we have never imagined, in circumstances that test our assumptions. This fresh insight motivates us to reevaluate our place in the cosmos and maintains the hope of finding extraterrestrial life. Is it possible that life exists in ways that we haven't even considered yet? Wherever you least expect it? With each new finding, we get closer to understanding whether or not our solar system is vast and alone in the cosmos. Every new piece of information gathered by the James Webb Telescope feels like a baby step closer to something truly remarkable, and the quest is far from done. Scientists are more optimistic than ever before that we might find proof of life beyond Earth using the current tools we have and the even more powerful ones that are on the way. finding signs of life in surprising locations. Space is so big and varied that finding life there needs to be an all-encompassing effort. This kind of study would be best initiated with planets that are similar to Earth and that orbit stars similar to the Sun. On the other hand, it's just as crucial to maintain an open mind and think about non-standard situations. While these stars may not be as luminous or hot as the Sun, they do offer some interesting places to look at the possibilities of life in different situations. Because red dwarf stars last so much longer than regular stars, the complex evolutionary processes that give rise to life can take their sweet time. Think about the TRAPPIST-1 system. It has 7 Earth-like rocky planets in orbit around a faint red dwarf star. 3 of these may be in the habitable zone, where liquid water may be present on their surfaces. The TRAPPIST-1 star gives off mild light that may be able to sustain life, despite the fact that it is smaller and colder than the Sun that warms Earth. Scientists are hoping to learn more about the possible life forms in the TRAPPIST-1 planetary system by analyzing the light that this star emits. With each fresh piece of evidence, we wonder, how could life evolve to thrive in these extraordinary settings? Following extensive analysis, the JWST has pinpointed this star in the constellation Leo, around 41 light-years away, a prospective location for future research. Leading researcher Ward Howard of the University of Colorado Boulder and a NASA Sagan Fellow couldn't contain his joy over these results. He made the comment that the JWST has made it possible to search for planets orbiting other stars with secondary atmospheres comparable to Earth's for the first time. If we want to know what's going on with these planets, he said, we must first know these stars. What further mysteries could the stars have in store for us? Proxima Centauri is the most prominent star in our galaxy because of how close it is to Earth, just 4.25 light-years distant from the Sun, making it the nearest star to our planet. From Earth, it is difficult to see this star because of its dim light. Because of its low luminosity, any planets that could support life would have to circle the Sun far closer than Earth does in order to keep the conditions favorable to life. Astronomers made a thrilling discovery on August 24, 2016, when they found a planet that was 1.3 times Earth's mass and located precisely in the habitable zone of Proxima Centauri. Light levels here are optimal, allowing ice to melt and perhaps allowing life to take root. Located at 4.6 million kilometers from its star, Proxima Centauri, the intriguing planet Proxima b orbits it. There are a lot of potential dangers that can make it hard for life to flourish because of how near it is. Solar winds from Proxima Centauri are so strong that they could deplete the planet's atmosphere, which is a big problem. Nevertheless, Proxima b is warmed enough by its star to retain liquid water, an essential component for life, despite these severe conditions. Tidal locking is another consequence of Proxima b's tight orbit around its star. Since of this, one side of the planet is constantly illuminated by sunlight since it faces the star, while the other side is always in the dark. One hemisphere could enjoy endless brightness, and the other could be ensconced in eternal night. This unusual circumstance makes for a striking contrast between the two. This is analogous to our planetary connection with the Moon, in which the same side of the Moon is constantly visible to Earth. Although Proxima Centauri is on the smaller side, it gives forth enough heat and light to create an environment similar to Earth's that could support life. Nearby stars and their planets have distinctive features that pique the interest of astronomers in the ongoing search for extraterrestrial life. Constant investigation into space and time brings us one step closer to the discovery of extraterrestrial life. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.